we've talked about how to format a chemical equation. Now we're going to talk about how to balance it. And this really starts with this idea that in a chemical reaction, matter is conserved. That means that atoms aren't created or destroyed. Instead, just the bonds between the atoms change. And when we think about a chemical reaction, what's really happening is that two elements or molecules or atoms are in space and they collide. We call this collision theory. And if they collide with enough energy, they'll be able to break bonds and form new ones and separate as two different molecules. They can collide and have not enough energy and then just bounce off each other and be the same. And so when we think about these chemical reactions and we read them, what we're really describing is a group of reactants that are colliding with one another, and that when they collide, they change their bonds to form their products. And so we won't be creating atoms or destroying atoms in these collisions. Instead, we're creating and destroying bonds between atoms. So that means that in our chemical equation that we write out, the atoms on the reactant and the product side need to be the same number. So we'll balance equations, and we're going to walk through with an example some of the steps to do that. So I tried to be as detailed as possible about how I balance equations in these 5 steps that are here for your reference. If you develop kind of a slightly different style, that's great. So first, once we identify our reactants and products and kind of format out our chemical reaction, we'll then look at the atoms that we have on both sides of the arrow. And our goal is to make sure that everything is the same number on either side of this arrow right here. So I recommend that you balance one element at a time, rather than trying to think through how to balance out all of the elements at the same time. And I always choose one of the ones that is the simplest. This tends to be a heavy atom, and it's really just because there tend to be less heavy atoms in the chemical reaction. I also look and try to find an element that is only in one of my reactants and one of my products to balance first. Sometimes you'll see an element is in multiple of the products or multiple of the reactants, and they're a little bit more challenging. So I'll start with the hydrogen. So I have 2 hydrogen in my starting, and the way I'm determining that number is I'm taking the subscript and I'm going to multiply it by the coefficient. Now, the coefficient is going to go right here in front of the molecule. And the subscript is the number of atoms that are in the molecule. And so for hydrogen gas, there's 2 hydrogen atoms that are bonded together. I don't have a coefficient yet. That's where I'm going to do my balancing. So I have 2 hydrogens right now in my reactant side. And if I look on my product side, this subscript 2 only applies to this hydrogen. I have 2 hydrogen. So right now, my hydrogen are balanced. Great. They have the same number on either side of the arrow. Let's look at oxygen. I have 2 oxygen in my, and I'll write oxygen because otherwise it looks like 20. I have 2 oxygen on my reactant side. And then when I look at my product side, there's no subscript. So that means there's only, it's the same as saying 1. So I have 1 oxygen on my product side. So these are not balanced. So to do that, I am going to add a coefficient to balance my oxygens, because the total number of oxygens will be that subscript times the coefficient. So that's going to be 1 times my coefficient will need to equal 2. And I'm choosing 2 because I have 2 on my product side, 1 on my reactant. I go to the side that has the least oxygen, and I'm basically going to multiply it to get a number that's equal to the other side. So if I multiply my water molecule by a coefficient of 2, if I have 2 water molecules, then that means I will have 2 oxygen atoms that will be part of my equation on my product side, and that will match the 2 oxygen that I have on my reactant side. So now my oxygen are balanced. Looking at this though, now my hydrogen are no longer balanced. So when I put that 2 in front, this 2 applies to the whole water molecule. So now I have not 2 hydrogen, but I have 2 times the subscript. I have 4 hydrogen. So with 4 on the product side and still only 2 on the reactant side, that's not going to work. So I go to the side that has the least, that's my reactants, and I think about what is a coefficient that I can multiply by my subscript. So this is my subscript to equal the number of hydrogens I have on the product side. And so if it's 2, then I will have 4 hydrogen total. So I'll put a 2 here. So now I have 2 times 2. That's going to be, so 2 is my coefficient and 2 is my subscript. That equals 4 hydrogen on my reactant side. And I have 4 hydrogen on my product side. Now everything is balanced. And when I changed this coefficient here in front of the hydrogen, I only affected the number of hydrogens in the chemical reaction. It didn't affect the oxygen. So my oxygen are still balanced. So I have a balanced equation, which it might be helpful to rewrite. I'll do that right up here. So we have 2 hydrogen gas plus 1 oxygen gas is going to form 2 water molecules in the gas phase. And I have 4 hydrogens on both sides of this equation, and I have 2 oxygens on both sides of the equation. When I'm balancing, I don't need to make every element the same number. I just need to make sure the same element is the same number on both the reactant and the product side. So as you practice these, and they take a little bit of practice, use these steps for balancing. And I'll show you a few more examples here that I'll walk through.